Problem 71, we have something similar to what we had problem 70. So what we want to start with is a force diagram for each block. I'm going to identify first the incline. I'm going to identify the incline so I can direct the normal force. It's always perpendicular to the incline. Tension. And it says, I'm told that the block is going to slide down the frictionless ramp, so that means my friction is going to oppose the slipping motion as I slide down the ramp. And that takes care of my 10 kilogram block. My 5 kilogram block. I'm going to have tension going up and force due to gravity going down. So I'm going to call that gravity, oops, not F, gravity 5 and gravity 10. The reason I'm going to do that is because I'm going to combine these and make a system diagram. System diagram will be connecting the two tensions. And if I just plug the little diagram into the bigger diagram, tension becomes internal to the system. And the only thing on the outside then would be force due to gravity 5. It's like I've taken the little diagram and plugged it into the big diagram. Now I'm going to rotate this just so that I can confine the motion to the plane, and I want the plane to be labeled the x-axis. You don't have to do this, it's just convenient to do this. Let's see, my original incline was 40 degrees. So now my force due to gravity is 40 degrees off of the vertical. I probably should have put this 40 degrees on here for clarity. There we go. Relative to this diagram then, that's the one I'm going to use to write my force equations. So I have some forces in the x direction. Force due to gravity, just the x component. All of friction, all of force due to gravity 5. Do the same in the y direction, all of normal force and a part of gravity. Since I'm confined to the plane again, acceleration in the y direction is going to be 0. My normal force will then be my force due to gravity y component. Y component is going to be the component that touches the 40-degree angle. So that's going to be M10 times G times the sine or cosine of 40 degrees. That's important because I know force of friction is coefficient times the force normal. And now in my case I can say force of friction is coefficient of friction times M10 G cosine 40 degrees. And I can make those substitutions into the x equation. Now the x equation I have the opposite of M10 G sine 40, right? That's the x component, plus my friction, which I have right here, plus the force due to gravity from the 5, so m5g. That's equal to my system mass, which is m10 plus m5, or just 15. I'll get to the 15 in a minute. Times my system acceleration. I'm ready to put in my numbers. So what do I have? Oh, whoops, this is a frictionless ramp. Oh, and I circled the wrong number up here, or wrong letter. Okay, let me fix that first. So tension is what I needed to have circled up here. And I don't have any friction, so I can get rid of that friction. I can get rid of that friction. Get rid of that friction. Let me draw that back in there. Okay, don't need friction there. Which means I don't need any of that. And I really didn't need to do that. Still have that part, still have that part, I just don't have the coefficient of friction in here. There we go. Why don't I just write that nicer up here? Okay, didn't write it any nicer, but I'm going to write it more compactly anyway. There we go. We'll get rid of these, actually. There we go. And now I can solve for my acceleration. Divide by the sum of the masses. And in equation form, I have my acceleration. Now if I substitute my numbers, and I'll plug those in my calculator. Alright, that gives me my acceleration in the x direction. And that's the end of the problem. I can box that in. I could just say 0.93 meters per second to the right or down the incline. That would mean that the small block then would be accelerating upward. So this one would go up. This one will go down along the incline, both with acceleration A.